Do you want to learn how to build your own AI tools to interact with network devices? Are you curious how you can connect large language models to real networks? Stick around because today I'm going to show you how. Hi, I'm Jesus Illescas. I work as developer advocate with Cisco DevNet. Today I want to share my experience building an MCP server which I developed for Cisco Live, called gNMI Body. This video is divided in 3 parts. In the first part, we talk about the architecture of gNMI Body from the software engineering perspective. In the second part, we will focus on the AI side, what considerations you should have in mind. And on the third part, we will check how this works in practice. One note, on this video I will not touch on what the Model Context Protocol or MCP is, what transports and features MCP supports. For that, you can go and look at Shannon's series of videos where he dips down on the MCP specification. Links in the description below. On this video, I will focus on tool calling, more specifically tool calling for network devices. For those who might be new to the term, tool calling is simply the process of giving an AI model the ability to use external tools. In our case, tools that can check the status of a router or a switch. With that in mind, let's get started. As you might already guess, gNMI Body uses gNMI to connect to network devices. gNMI stands for gRPC Network Management Interface. In my case, I didn't want to parse CLI commands, have to deal with regex. I also didn't want to use a framework. In the past, I built tools using PyATS, which is a network test and automation solution framework. And I had so many problems, slow connections, timeouts, or the structured return. I wasn't that happy with that, so I decided to try a new approach. I wanted to work with model and structured data. In networking, that means young models, but that has their own challenges. To work with young, you need to pick a transport and find the path of the data you want to get. For transport, we have netconf, which uses SSH, and restconf, which uses HTTP. But I wanted to play with something newer and more performant. And that's when I chose gNMI, which is pretty fast. Picking gNMI was easy. Finding the path, on the other hand, that was hard. In my case, I'm working with XRD, which is iOS-XR in a container. iOS-XR has 3 kinds of young models: Cisco XR native models, Cisco XR unified models, and OpenConfig models. So which one to pick? Something I knew was important for my use case is that my tools can be used with many platforms, not only XR. So I picked OpenConfig. OpenConfig is a set of vendor-neutral young models for network devices. Once I have the model, now it's time to get the data. But then, how do you know where it is available? For this, the OpenConfig Schema Explorer was a very useful tool. I was able to see what models are available. Once I knew which model I could use, it was an all and good trial and error. I started to query the device, look at the amount of data that came back, and figured out which specific fields were actually useful. Now the question is, what to build? I decided to go with a simple use case. What's configured on the network devices and what is the state on the devices. So I went ahead and started to create some basic tools. And here comes the first big consideration. experience matters. What do I mean by that? Two things. First, what should I retrieve from the devices? And second, what data is relevant? In the first case, I decided to go with the basics. Interface config state, protocol config state, logs, system config, as we know, the basics. As a network engineer, I know this will give me an initial picture of the state of the device. For the second case, what data is relevant? Like I said, it was trial and error. Sometimes the junk path didn't provide any info, while in other occasions it was too much. So how do you know what is relevant and what is not? Large language models, or LLMs, can get easily confused. Again, this is the part where the experience as network engineer was crucial. From the data that I got, I can immediately see what pieces are useful to understand how the devices are configured and what is the state. Experience still matters. Otherwise, the tools will provide wrong data to the LLMs, which will provide wrong answers, or even worse, perform wrong actions. With these considerations in mind, I can start to visualize how to build my MCP server. First, I need a gNMI client. Then I need to parse the data from gNMI. And lastly, I need to present the information to the LLM and or user. For the gNMI client, I decided to use an existing library, gNMI in my case. One tip: when working with external libraries, use objects or structs to encapsulate data that is sent between your modules and the external libraries. This will help to create a nice separation of concerns. It's easier to write tests for it, and you can do validations on the data. For example, instead of my code handling directly the raw dictionary that gNMI returns, I created my own objects: error response, feature not found response, and success response, that work as a separation layer between gNMI and the rest of my application. This means that if in the future I want to use another gNMI client, I only have to change that part of the code and the rest of the application doesn't have to change. To present the information to the LLMs, many frameworks provide a way to interact natively with tools. But as you know, MCP is the best option for now. In my case, I decided to use two entry points for my code: a traditional command line interface for humans and systems, and an MCP server for LLMs. The CLI version was pretty useful for development and debugging. My workflow is: first, it works on the CLI, then I register the function with MCP. Let's explore now the second part of this video: what considerations you should have when working with LLMs. The first one, and most important, is context is key. In fact, at the time of recording this video, there is a recent term called context engineering. Stealing a quote from Toby Lutke, CEO of Shopify, context engineering is the art of providing all the context for the task to be possible, solvable by the LLM. Basically, this means to provide the right context to the LLM to get the right results. Imagine you are teaching someone to drive. You wouldn't just hand them the keys and say, "Go." You will provide context, explain the rules, show them the pedals, and guide them. In networking terms, this is the difference between running a show tech support versus running a few targets commands like show IP interface brief and show BGP summary. If you provide too much data to the LLM will be lost. And if you provide too little data, the LLM will not be able to help. There's a great video from LangChain that explains more. You can find the link on the description below. So how do you know what is the right amount of data? Again, experience matters. By looking at the output from gNMI, I can determine what I consider useful. But as you may know, it's always better to have a second opinion. So use another LLM to question what it considers relevant. And from there is rinse and repeat. One way for me to handle context was through abstractions. Instead of providing tools for every single command out there or path, in my case, I prefer to provide an interface for a singular purpose. For example, instead of creating a tool called getInterfaceState and another called getInterfaceConfig, I created a single more abstract tool called getInterfaceInfo. The LLM doesn't need to know about the different gNMI paths for state and config. It just needs to know it can check an interface. My tool handles the complexity of gathering and combining that information behind the scenes. And as a developer, I can make sure I provide only the most relevant data. But actually, before we can get something from the devices, the LLM has to pick the right tool to call. So how does the LLM know which tool can be the best to use? In this case, there are two parts: the name of the tool and the docstring. As you know, one of the hardest things in computer science is naming things, and this is not the exception. Picking the right name will make the difference between the LLM using the tool you intended to be used and ignore it, or worse, use it incorrectly. A tool name check connection is straightforward and clear, unlike one name conch. The latter might confuse both developers and LLMs about its purpose. So as you can imagine, it's very important that your tool describes very well its intention on its name. Docstrings should be completed, meaning provide a summary of what the tool does, description of the input and output parameters, and their type. Notes and examples are also useful. If you think about it, we are just applying the same software engineering best practices we use for any good library or API. Any developer needs clear function names and good documentation to use a tool effectively. And an LLM is not different on that. So now let's take a look at this in action. As you can see, I am already on a sandbox, in this case XRD, which is the one I use for development and testing. I'm already connected to the BPM, so I have full reachability to the XRD containers. I'm using the topology provided by the sandbox. In this case, it's an MPLS network with segment routing, very SP oriented. But in this case, what matters is that I have a network with several XRD routers using several functions. In this case, for example, I have a PCE, I have a virtual route reflector, I have P routers, which are transit, and PE routers, which have customer routes in this case. To get started, let's examine the CLI part that I commented that I developed, which is pretty handy so far. The feedback loop is super fast, so that's why I prefer to develop using the CLI. In my case, I need to type UV-ROM, and if you don't know what UV is, it is a package manager for Python that can do a lot of stuff. I highly recommend to take a look and start using it. So far, it's been a great experience. So let's go back to the CLI, and in this case I need to type gNMI body.py, and if I don't type anything, I will see the general help. Something important, the way I design my CLI is that I need to provide an inventory. And the inventory basically is the information on how I can reach to the devices. So for example, in this case, you can see it's just pretty basic information, right? IP, the name of the device, and the credentials, username and password. Somehow I need to connect, right? So that's how I'm providing this to my tools. Ideally, this will be a request to another system that has already this information, but for now, this JSON file is good enough. Going back to the CLI tool, I need to provide the inventory. So dash inventory, and in this case, XRD sandbox. And now let's pick an option just to see how it works. In my case, I'm going to go with the network command. And as you can see, the network command has different configurations that I can use. In this case, for example, let's see interface. And if I don't know what to type else, I can just press enter and it will give me some examples. So in this case, for example, let's go with the first one, just a device, dash device. And in this case, XRD1 because it's the first one. Now it's connecting to the device and grabbing the information using gNMI. And as you can see, I got my reply back. Now, this reply has certain structure that I consider is useful. Like I commented as network engineer, this is the information that I think it will be mostly useful for LLMs, and I can take care of that part. In this case, my reply has the device name, IP, network operating system, the type of operation, the status, this operation was successful or not successful. And in this case, for example, I can present the summary of data, of interfaces. So as you can see, the LLM is not aware that I'm using gNMI, is not aware of the path that I have to use with Yang to retrieve this data. And that's the abstraction I wanted to use in my case. So if I scroll more, you can see I have a summary of the interfaces, which is quite nice and quite useful. Now that we have seen the CLI part, let's start exploring the MCP part that I think everybody here is interested. So to get started, let's see a common client that we can use to test our tools if they work or they don't work, which is the MCP Inspector. In my case, for example, let me go back to my README. I already have prepared everything. And in this case, for example, let me copy and paste this command, which will start a server using Node.js. If you don't have installed, you will need to install it. And as you can see in this case, it's pretty fast. So the first thing that I need to do is to connect to my server, clicking on connect. I can see some information that the server started. And in my case, for example, I only develop tools. There are more options with MCP. Every time they are adding more. But in my case, for this use case that I develop, I only care about tools. So let's click on tools and now let's list the tools. And in this case, for example, you can see I have all the tools that I developed here. So let's see, in this case, the get interface info. In this case, I have the name or the function. Like I commented, naming is super important. And from the docstring, I have a summary of what this function does. And like I commented, it's very, very important to have very good documentation. So the LLM, when they see this function, they can understand what it does, what parameters I need to provide, and what parameters or information will return. So in this case, because we already use this function on the CLI, let's call again XRD1 and run the tool. So it's running and I have a success. And if I scroll down, you can see I'm having a similar structure because behind the scenes, I'm using the same mechanisms for my CLI or for my MCP server. This is really nice because I can ensure what the LLMs will see by just using the CLI. Now let's take a look at how you can connect your MCP server to an actual agent. And for that, I'm going to use my IDE as a MCP client. There can be many, and there are many MCP clients, but for making this demonstration easier, I'm going to use my IDE. And let's go back to Cursor, which is the IDE I'm using right now. And in Cursor, I'm going to settings. As you can see, I'm already have configured gNMI body in my case, but if I click on this pencil, we can see the configuration. And as you can see right away, I'm also using UV. And in this case, I'm telling UV, hey, I want to run this Python program using these libraries. And I'm also passing my inventory as an environment variable, which in my case is pretty handy. And if you see in this case, I don't have to worry about activating my virtual environment, which is super nice. That's why I really like UV. So I can see MCP is already configured and is already running. On the settings, I can see it's enabled and I already have some tools discovered. If I expand, you can see, for example, here are the functions that I provided on MCP. And in this case, for example, if I hover, you will see the docstring. Like I commented, this is super important. And just to comment, this is very specific to Cursor. How you will see it on other MCP servers is of course different. But now let's see this in practice. And for that, let's go with the actual agent. So let's go, and in this case, open the chat. And now in the chat, as you can see, I have Claude for Sonnet. I have in agent mode. There are multiple modes, but in this case it's agent. And what I'm going to actually, let's remove this one so it doesn't have any context. And what I'm going to do is to write an exercise and see if the agent is able to find my tools and use them. And for that, let's see. I need to check if there are any BGP issues across all of my PE routers. And let's see. So right now it's started to work. Something that I like about Cursor is that we can see the thoughts of the thinking LLMs. And as you can see, I've already have some description on what it's going to do. It already found some tools. And as you can see, it used the tool called get devices in my case to get the list of the devices available on the inventory. And now it's calling another tool called get device profile, which I was thinking when I developed a gNMI body, hey, it will be useful if I can provide to the LLM if this is a route reflector, if this is a PE router, a P router. Let me speed up this by the magic of edition and show you the final result. So the agent finished, and I will scroll up to see what the agent did. In this case, like I commented, it was looking at the get device profile. And for example, in this case for XRD5, we can see some information. And here, for example, we can see that in this case, XRD5 is a P router. So that's good. It's not the kind of device that I was asking for. So I will scroll down and we can see, okay, Great, I've identified your PE routers in your network, in this case XRD1 and XRD2, and it gives me an information. Now, like I commented, I was asking about BGP, and based on the docstring and also on the name of my tools, it found that in this case there's a tool called get routing information. And in this case, for example, it specified to use BGP, and that's a design that I took. And in this case, include the details of all the BGP. Otherwise, the way I design the tools is it can also provide just a summary of BGP, but in this case, Cloud considered it is good to see all the details. And as we can see, there's a lot of information there. In this case, it also tried to get the VPN information. I can see it also tried to use the get logs tool, but there was a problem with the parameter minutes. So what I can see is that most probably it was trying to use a type that was not correct. And what that is telling me as a developer is that, hey, I probably should have to handle this kind of cases, right? What if Cloud is sending a string and then I know my tool is receiving integers, right? That's something I could handle. So maybe, yeah, that's a consideration and an improvement for the tool. So now let's continue and we can see the final analysis based on the information provided by gNMI body. So in this case, for example, we can see XRD1, we can see the router ID, the state, the AS number, prefixes, the BGP numbers, and for example, the L3 VPN, how it is. And the same for XRD2. So as you can see, I think Claude did a very good job. In this case, it provided me an analysis of the state of my PE routers. I didn't have to specify the name of the device. It was able to figure it out based on the tools, and I consider the information is useful. This can be improved, of course, and that's when I keep saying experience matters, because we as network engineers, we know what data is relevant and we can put it in our MCP tools. But now I know that as a good engineer, you want to know how this works. So let's go and take a look at the code. The first thing that I would like to point out is the structure of my project. As you can see on the root directory, I have two files, gNMI.body.py and MCP server. Basically, these are the entry points for my application. gNMI body is a CLI entry, and MCP server handles the MCP part. Behind the scenes, they connect to the same functions that are available. That's why I know that what it is on CLI will work on the MCP side, because they have the same functions in common. So for this video, let's focus on the MCP server. And for that, as you can see, I'm using a library called FastMCP, which is an SDK from the MCP community. It's super easy to use, and I highly recommend to use it rather than implement your own SDK. But I mean, who am I to stop you? So go with whatever is better for your use case. Now let's scroll down, and in this case, this is just some logging, because there are libraries that I'm using that sometimes they send login messages to the standard output. And in this case, the transport that I'm using for MCP is standard output, and they can confuse the LLMs with login messages. So in this case, I decided, hey, I need to quiet those libraries, and any login message will be to the standard error output. So scrolling down more, you can see I'm starting my FastAPI MCP server. In this case, there is no transport defined, so it will be a standard output. And for example, registering a tool is super easy. You only have to use this decorator, mcp.tool. And that's how a Python function will be on MCP. Now, since I'm a bit lazy, I don't want to type a lot of MCP tools on my code. So I decided, hey, let's just use a wrapper for that, and that's it. And that's what I'm doing a bit below. As you can see, I'm importing the Python functions that I have defined in another file. And in this case, I'm just registering those functions with MCP. And that's all the magic. As you can see, it's not something that difficult. It's super easy. And that's why MCP is quite popular, because it is a very, very simple protocol. And then I had my main function, basically run MCP. And that's it. But I know you're wondering, hey, that's all? Where are the docstrings? Where are the functions? Well, as you can see, I'm importing my functions from another module called API. So in the API module, you can see a lot of imports, and below are the functions that the agents or LLM will see. In this case, for example, you can see a clear name, the input, the type, and what is returning, a docstring with information of what the function does, some examples, and what is returning. And in this case, you may be wondering, hey, that's all? Yeah, that's all, because it doesn't make sense for the LLM to know the internal implementation, and I consider it's better for me to put the actual implementation somewhere else. You know, like following good engineering, software engineering practices. I would love to keep talking about how the code works, but this video is already a bit long, so I think it's better to stop it here. But if you have any comments or questions, put it on the comments below. I hope that by now you have a better idea on how you can design your own MCP server. What considerations you need to keep in mind. The key takeaway is that you, as a network engineer or developer, already have the most important ingredient: experience. Combining the experience with these new AI tools is what will unlock the next level of network automation. And if you don't have experience, remember, fundamentals are still the foundation. Don't get discouraged and deep dive on them. But now is your turn. Go ahead and grab a DevNet sandbox. Remember, they are free. In this case, the XRD sandbox, and play with gNMI body. On the XRD sandbox, you will find instructions to bring an MPLS network using Docker. The links for the sandbox and gNMI body are on the description below. If you enjoyed this video, please hit the like button, subscribe to the Cisco DevNet channel for more content like this, and leave a comment below with any questions you have. Thank you so much for watching.